All right, so here is the structure for the test. So again, 5 questions. The first question is going to be a sum and difference formula and double angle formula question based on the same angles. Then we're going to have 2 trig equations to solve. Then a law of sines question, a law of cosines word problem, and then polar coordinates and an equation conversion. And then the image here to the right is the formulas that'll be on the test. So you'll have the unit circle, all 3 Pythagorean identities, the double angle formulas, the half angle formulas, the sum and difference formulas, all 4 of them. And then over on the right, under the unit circle, there's the law of sines, one version of the law of cosines, and then the 4 polar equations. So big giant list, you're not going to use everything on the list. You probably use everything on the right, but not everything on the left. So which question would you guys like to start with? All right, so double angle in the first one. So I'm going to pull exam practice problem 4, because this is the closest format to the way the first question is going to look. It won't be a quadrant 1 angle on the test, but we'll have this kind of setup. So here we're told the sine of alpha is 1/8, and alpha is in between 0 and pi over 2. So alpha in between 0 and pi over 2, 0 is our positive x-axis, pi over 2 is our positive y-axis. So this is a quadrant 1 triangle. And now we know sine is some old hippie. So that is opposite over hypotenuse. So 1 is our opposite side, 8 is the hypotenuse. And I'm going to call the third side x. So we're going to use the Pythagorean theorem to solve for that third side. So x squared plus 1 squared equals 8 squared. So x squared plus 1 equals 64. And we minus the 1. So now x squared equals 63. And we square root both sides. So now we have the positive or negative square root of 63. So we look back at the triangle. X is the positive x-axis. So we're going to use the positive square root of 63. So we can now say that the cosine of alpha is caught another hippie adjacent over hypotenuse. So square root of 63 over 8. So I've got my cosine alpha and my sine alpha. Now I'm going to use the second setup. They tell me the cosine of beta is -1/2. And that beta is in between pi and 3 pi over 2. So pi is our negative x-axis. 3 pi over 2 is the negative y-axis. So we're in quadrant 3. And then I label beta. Now cosine caught another hippie, so our adjacent side is the -1, and the hypotenuse is +2. And now we're going to solve for the third side, so I'll call that y. So -1 squared plus y squared equals 2 squared. So we have 1 plus y squared equals 4. Minus the 1 over. Y squared equals 3. And now we square root. We've got that plus or minus question. So now we zoom back up, look at our triangle. The y side, the opposite side, is going down in quadrant 3. So we are going to choose the negative square root. So y is negative square root of 3. And now I can write down that the sine of beta is negative square root of 3 over 2. So I've got sine alpha, cosine beta, and sine beta. Now I have enough information, I can answer the original question, the sine of alpha plus beta. So on the front of the test, we can look this up in the list. The formula is sine alpha cosine beta plus cosine alpha sine beta. And now I'm just going to fill in the pieces I know. So I know sine of alpha is 1/8. And I know cosine beta is negative 1/2. Cosine alpha is the square root of 63 over 8. And the sine of beta is negative square root of 3 over 2. Now we could multiply through, clean that up, write it as all one giant fraction, but WebWork will take the answer just like that, and I will take it just like that on the test.
Excuse me?
You don't have to multiply them. Go for it.
So how do you know for the right side or the right triangle that it will be in quadrant 3?
Because they told us beta was between pi and 3 pi over 2.
Ah, okay. I didn't see that.
Yeah. So
All
they
right.
will tell you in the setup for the problem where the angles are and then one of the trig functions.
Okay.
All right, so this is what the first part of question 1 on the test looks like. We got our sum and difference question answered. Now, as a follow-up question, using the same angle setups, it's going to ask, what's the sine of 2 beta? Now, the formula is sine 2 theta equals 2 sine theta cosine theta. That's our double angle formula for sine. So when they're asking sine 2 beta, that's going to be 2 sine beta cosine beta. So I'm just changing out the thetas for betas. And then I just need to fill in what I already figured out about sine and cosine of beta. So sine of beta is negative square root of 3 over 2. And cosine of beta is negative 1/2. Now the numbers on the test will be uglier. Like both of the triangles will look more like the numbers we got in triangle A, but they're not going to be a quadrant 1 triangle. But that's all you need to do for the double angle one. You'll already have the setup from the first part, and you're just filling in, answering the double angle formula for whichever angle they indicate on the test. So it's very similar to the writing assignment we did on this section. On the writing assignment, you had the setup at the top with the triangles, and then the writing assignment actually asked 4 questions based on that setup. This is just the same setup, just shortened to 2 questions. One of them is a sum and difference, one of them is a double angle. All right, what problem do you guys want to look at next? The polar ones? Sure. All right, let me
Excuse
go.
me.
Yep.
Okay, so could you try writing this down? So it would be 10 parentheses I think theta,
Uh-huh.
and then equals square root 3 over 2. Well, no, like square root 3 divided by 2. So like the top half would be square root 3 over 2.
Is the 2 inside the
Like
square root?
no, like square root 3 over 2 is the sine value over cosine.
Oh, okay. So you mean like this.
Yeah. And then over 1/2.
Okay.
So if you canceled out the twos, it would be square root 3 over 1.
Uh-huh.
And I think they had a question that was like 10 parentheses theta equals square root of 3 or something like that.
Mm-hmm.
You see where I'm getting at? I don't know how to like formulate the question I'm trying to get at. Um, it was a weird one I had. Uh, yeah, actually, just move on. I'll try to find it in my notes.
Okay. Like when we do sine over cosine and we get a tangent value, like sometimes the tangent values are bigger than 1 or smaller than -1, and that's okay. Tangent is allowed to roam wherever it wants for its output values. That may not have been your exact question, but that's just like what I'll say for it right now. All
Well,
right,
no,
so
I think I had to work. I think I had to work backwards to find out that it was square root 3 over 2 over 1/2, because I think it just gave me like,
just the square root of 3.
or it might have been like 10 of theta minus square root of 3, and you had to move the square root of 3 over to the other side.
Yeah.
I forgot. I'm trying to find it.
All right, I'm going to do a polar example, but then if you find it, we can go back and do that.
Okay,
All right.
sorry.
No, it's okay. All right, so problem 20 is converting a XY point into a polar point. But they've added this extra qualification on top that's going to limit what we can do for the angle. So here, our angle has to be between -pi/2 and +pi/2. So one of the things this is telling me is that my angle is in radians. So I can't use a degree number for my answer here. It has to be radians to be between those two qualifications. Now, our polar equations are x equals r cosine theta, y equals r sine theta, x squared plus y squared equals r squared, and tangent theta equals y over x. So I have an xy coordinate. Xy equals -8, 5. I want to figure out the r and the theta that go with this x and y. So I want to use a formula that has x and y and r in it. So which of our 4 formulas has x, y, and r? Yep, x squared plus y squared equals r squared. So I'm going to fill in x and y, and I'll solve for r squared. And this is really just the Pythagorean theorem, so it's, a calculation we've done over and over and over again. So we have 64 plus 25. So I have r squared equals 89. And then I square root both sides. And I have that plus or minus question. Now, right now, it could be either. So I'm just going to leave it as plus or minus the square root of 89. I'm going to go play around with tangent. because that's my formula that uses theta and y over x. So I have the tangent of theta equals, and then I'm going to leave some space. The y value is 5 over the x value is -8. Now to get theta by itself, I have to undo the tangent function. And that undo is inverse tangent. So I'm going to inverse tangent both sides. And now I have theta equals, and then I'm going to crunch that on the calculator. Inverse tangent of 5 divided by -8. And my calculator spits out -32.0053, blah, blah, blah. But I put in a question mark after that. What's wrong with that? It's in degrees. So -32 makes sense as a degree number, but that's not a radian number. Our -pi/2 is -1.57. This is way bigger than 1.57. But this is the most common mistake on this problem, is just having your calculator in the wrong mode. So if I flip it over to radians, now it gives me -0.558599, whatever. So that's the angle we're going to use, and that's the angle we're stuck with. I can't change this angle. This number is between -1.57 and +1.57.
Excuse me.
Go for it.
Doesn't theta stand for like angle or
Yes.
degrees?
Well, it
But
can
we
be
have-
degrees or radians.
Okay.
And in
What
this
does-
one, because they told us theta was between -pi/2 and +pi/2, they're telling us theta has to be in radians.
But they're both like they're equal, right? So it's what
They're
is a
equivalent answers.
so that's 32 degrees, but
Yep.
it's 0.55 radians.
Yes.
Okay. Okay.
So the -32 degrees, or the -0.55 radians. If I plot that, -32 degrees goes down into quadrant 4. So -0.5585 radians, same location, down into quadrant 4. All right, but where is the point they gave us? So they told us -8.5. Where is -8.5? Yep, the second quadrant. We're going to go left 8 and up 5. So certainly there's an equivalent theta that's in quadrant 2 that would get us to that location, but I can't mess with my angle here. So I am stuck using the -32 degrees, the -0.55 radians. So I'm looking in quadrant 4. What I have to decide is which of the radiuses goes with that angle. Do I want to use the positive radius or the negative radius? So if I'm looking in quadrant 4, do I want to move forwards into quadrant 4, or do I want to move backwards to get to quadrant 2? So I think of polar coordinates, I very much think of like sitting on a spinny chair. So we start at the positive x-axis, and then I rotate, and I'm looking in quadrant 4. If I use a positive radius, I'm going to move forward into quadrant 4. But my point is behind me in quadrant 2. So I have to use a negative radius to put my chair in that location that they said they wanted me to move to. So since we can't change the angle, we have to change the radius. So it's just because the angle is the opposite quadrant from where the actual point is. So we'll have the negative square root of 89 with the negative 0.5585 radians. Or 5586 if you want to round it. Either's fine. So that is the only answer that WebWork will accept. And with the way the question is written on the test, that is the answer that needs to be on the test. Now, certainly there are equivalent points to this point. So if I added pi to my negative 0.55, I'd be adding 3.14. So I'm going to get like 2 point something, which is well bigger than my pi over 2. But if I used that 2 point something angle, I could use a positive radius with it. But it's just not an answer that WebWork will accept, and it's not the answer I want on the test. But if you did that, I'd still give you most of the credit because you are identifying the correct location and an equivalent polar point.
Hello?
Yep.
So would it just be a positive 0.55 for the angle, is it coterminal or just the opposite angle?
No, the positive angle would be in quadrant 1. So that's not coterminal, and it's not the equivalent angle for quadrant 2.
Oh, what's the equivalent angle?
So the equivalent angle is I take my location and I add pi to it. So the equivalent point, not what we can use as the answer, but another point would be positive square root 89 and the negative 0.5585 plus pi.
And that's just the location of the other angle.
Well, that's the same polar location. It's the same quadrant 2 point at negative 85. It's just a different number way of writing that location in polar coordinates. I could also use coterminal angles, but then the angle is going to be well outside the negative pi over 2 to positive pi over 2.
But that's the angle for the quadrant 2, this formula or this point.
So the first one is technically a quadrant 4 angle. So we had to use a negative radius to move our location into quadrant 2, like to move the polar point into quadrant 2. The other point I wrote is a quadrant 2 angle, so we need a positive radius to keep it in quadrant 2. It's whether I'm like looking in quadrant 4 or if I turn 180 degrees and now I'm looking in quadrant 2. If I'm looking at quadrant 2, then I want to move forward into quadrant 2. So that's why the quadrant 2 angle gets a positive radius, but the quadrant 4 angle gets a negative radius. It's which direction you're looking for which way you want to move for the radius.
Oh, okay. So it's more, that's cool. It's like a set of directions.
Yeah.
Okay. Thank you. Oh, I also have that question. I found it.
All right. Which one is it?
It's cotangent of x plus positive square root 3 equals 0. And
All right.
it's finding all the exact solutions, 0, theta, 2 pi.
Theta or x?
Theta.
Okay.
Or actually x in this one, I guess.
Yeah. I mean, I've made that typo before, so I wouldn't be surprised if WebWork did it. But this is solving a trig equation. Now, this one's a little more complicated than what's on the test. You're not going to have to do a tangent or cotangent equation. So cotangent of x plus square root of 3 equals 0. So we're going to minus the square root of 3 over. So we have cotangent of x equals the negative square root of 3. Now, this is normally the point where we would go to the unit circle, but the problem is the unit circle doesn't have cotangent on it. It's only got sine and cosine. So I've got to make some changes, some think about it steps to get to where I can use my unit circle. So I know cotangent is the reciprocal of tangent, and I know tangent is sine over cosine. So cotangent is the same as cosine x over sine x. Now, again, cosine never equals the negative square root of 3. That's too big. But if I look at my unit circle, almost all the sine and cosine values are over 2. So I'm going to make some weird adjustments to this negative square root of 3 over 2. So the negative square root of 3 over 1, that's still an equivalent number. And then I'm also going to sneak back in. I'm basically multiplying the top and the bottom by 1/2 over 1/2. So it's still the same size. I'm just making it look a little bit different. So this is one setup I can have. The other setup I can have is going to look almost identical, except I'm going to move the negative to the bottom. Now this is something I can take to the unit circle. So I can literally find where is cosine negative, that's the left side. Where is sine positive? This is quadrant 2. So long cosine, short sine. This is 5 pi over 6. And then technically this is where our plus 2 pi k shows up. And then our other location, cosine is positive, that's to the right. Sine is negative, that's down. So this is a quadrant 4 angle. The quadrant 4 over 6 angle is 11 pi over 6. Now the x value in there wasn't 2x or 1/2 x, it's just x. So that is our general solution. And then those two angles that we see, those are the only solutions from 0 to 2 pi. So we had to massage the equation a little bit to finagle from cotangent into sine and cosine.
Also so I think where I also got confused was I guess flipping the negatives. So is it plus or minus because it's a square root 3? We have to put the plus or minus.
We're not putting a plus or minus. What I'm doing is I'm moving a negative that they gave me. So they gave me negative square root of 3. So originally I just left the negative on top, but technically when I have a fraction and it's a negative fraction, I can associate the negative with the top or with the bottom of the fraction. You could also think of it like I multiplied by -1 over -1, and that would move the negative sign to the bottom if I multiplied the tops and multiplied the bottoms. So I'm just looking at two different ways, two different fractions that reduce back to negative square root of 3. I only moved the negative so you could see that this first one is quadrant 2 and this other one is quadrant 4. So you can see that both of those produce a negative square root of 3 for the cotangent.
Okay. But okay, so uh I think the problem we just did, it was negative. It was 5/-8.
Mm-hmm.
But if you put the negative to the 5, it makes a completely different triangle. Or
But
wait,
the
yeah, doesn't
inverse
it?
tangent of that would still be the same angle.
Wait, so you can move the negative from the 5/8. You can move the negative to the 5, and it'll still be the same.
Inside the calculation for the angle, yes. Now, if we
But
changed the negative on the point, you're right, it would be a completely different point, but the angle calculation would be the same number for both of those triangles.
oh, like typing it in the calculator.
Yeah, so typing
But
it in the calculator, you could move the negative, but you can't just move the negative in the point that they gave us.
okay, okay, okay. Okay. Wait, are you drawing the triangle from the coordinates, or
In the
right?
polar equation, yes.
Because I'm looking. So right now I'm looking at 10, or I'm looking at inverse 10 parentheses 5/-8,
Hmm.
which is where I think you drew the triangle. But you're not pulling those numbers from the parentheses. You're pulling them from x comma y.
Yeah.
Okay. All
So I
right. Now it
didn't
makes.
draw the triangle until after I'd calculated the angle.
No, I think I get it.
All right. Now, the other polar question we're going to get is problem 21. So I want to make sure we tackle this one too, just so we got both sides of the polar. But real quick, I'm also going to grab the formulas again. All right, so we got told,
Wait, excuse me.
go for it.
Just right before you start, sometimes, so most of these problems on web work, they would end up being such and such plus 2 pi r, or 2 pi k,
Right.
2k pi, one of them. But I think a few down the line in the web work would end up being just plus pi k.
Yes.
No, yeah, I didn't understand that.
So those happen when you have like 2x equals like pi over
I mean,
3 and 2x equals 2 pi over 3 with the plus 2 pi k. Like this is when you look up the two locations on the unit circle, you can get something like this. And then to get x by itself, you divide everything by 2 or multiply everything by a half. So we end up with x equals pi over 6 plus pi k. And x equals 2 pi over 6 is pi over 3 plus pi k.
okay, and that's if the parentheses is like 2x 2 theta or something.
Yep.
Okay, now I get it.
And so whenever you had that 2x or 3x inside, this is where you have to use k values to get more solutions. So k equals
Okay.
0 would give us pi over 6 and pi over 3. K equals 1 would give us pi over 6 plus pi is 7 pi over 6. And pi over 3 plus pi is 4 pi over 3. So this one would have 4 solutions.
So what if it was if this I think I had a problem with this one too. If it was 1/2 x and you have to multiply by 2, I mean it wouldn't be 4 pi k, would it?
It would be.
It would.
Yep.
I was solving it I was solving it just fine using 2 pi k. I think I multiplied the answers by 2. So if it was pi over 6, I'd put pi over 6 times 2 over 1.
Yeah.
That
So,
that still works.
yep. It does multiply the 2 pi k to 4 pi k, but it turns out we don't get extra solutions from it. So if you actually
Ah,
forget the
okay.
2 pi k, you'll still get the right answers.
Oh yeah, because the bounds. I'd be in trouble if it was like
If it was
zero
a 2x
theta six
inside.
pi.
Well, no, if it was 0 theta, then it's just 0.
Well, no, if it was like zero, less or equal to theta, less than, or no, yeah, less than 6 pi or something.
Yes, then you would have to use k values because they made the solution range bigger.
And then the the 4 pi k would actually matter.
Yeah. But we don't change the 0 to 2 pi bounds on the test.
Okay.
But yeah, if you have a problem, and there's one in the practice problems that does this, that has the 1/2 x equals, you multiply by 2 here. So you get 2 pi over 3 plus 4 pi k, and then multiply by 2. You get 4 pi over 3 plus 4 pi k. So the k values, if I plug in k equals 0, I get those two solutions I see. K equals 1, when I add 4 pi to those, that's going to be way bigger than 2 pi. When k equals -1, I'm going to get negative numbers, which is less than 0. So when it's 1/2 x or 1/3 x, whatever, like when that number is a fraction smaller than 1, it makes our plus 2 pi k bigger. So it means we're not going to get extra solutions. In fact, sometimes multiplying the number will actually make like the second equation, it'll make the results in there too big sometimes. You can actually lose solutions when you have to multiply by a number bigger than 1 because the x was a number smaller than 1, the value on the x. So that's like the end result of solving some of those equations, all the different ways it can kind of go.
I also found the class. I don't think the class can hear me, right?
Yeah, sort
Oh,
of.
they can?
Yeah.
Oh, okay. Well, I did find like a I don't I think you might have showed it showed us once to so if it was like 6 sine, well, let's use an easy one. Um yeah, if it was like 2 sine parentheses 3 theta equals 1, and I think it's let 3 theta equal u,
Yeah, that's one way
and
to work
so
it.
and then it would be sine of u equals 1/2, and
Hmm.
use that 1/2 to find the unit circle. uh what are they called?
Angles, the values.
Yeah, is pi over 6, what would we call that? It's not an angle, right? It's a
Yeah, it's an angle.
Oh, okay, so we would use the corresponding angles from 1/2,
Hmm.
and then you'd go back and I didn't get this part though. So it would be, since you let u equal 3, or if you let 3 theta equal u, when you go back you have to multiply those answers by 1/3.
Yep.
I didn't understand that part. I learned that part off of, I think, Google, but I don't get why the 3 theta turned into a 1/3. Or
Okay.
yeah, 1/3. Like, why do I have to multiply that by 1/3? Yeah.
All right. So when we have sine of 3 theta equals 1/2, sine is 1/2 at pi over 6 and 5 pi over 6 on the unit circle. With the 3 theta here, what would I do to 3 theta to get theta by itself?
Ah, okay.
I divide by 3, but dividing by 3 is the same as multiplying by 1/3. So that's where the 1/3 is coming from. So now
Okay.
we'd have pi over 18 plus 2 pi k over 3 and 5 pi over 18 plus 2 pi k over 3. And we'll have to use three K values, not K equals 3, but three different K values. We'll have to use K equals 0, K equals 1, and K equals 2 to get all 6 solutions that are between 0 and 2 pi. You're not going to have one that ugly on the test, though. 3 theta is just extra work that takes too long. But that's how you finish that one for the homework that did that. All right. I'm going to move us back to this polar equation. So x squared plus y squared equals negative 4y. I need to rewrite this Cartesian equation, this xy equation, into a polar form. So I want to write it so it's only r's and thetas. So 2 ways to do that. One is I actually have here a formula that x is the same as r cosine theta. So everywhere there's an x, I can write r cosine theta. And everywhere there's a y, I can write r sine theta. And then technically, that's a polar equation. So for the test, you do that, done. The problem is WebWork wants us to get it in the form r equals. So we're going to be a little more creative for solving this in WebWork. So x squared plus y squared, that sounds real familiar. Why is that so familiar? What do I know about x squared plus y squared? It's r squared, because that's one of our formulas over here. So that means instead of x squared plus y squared, I can literally write r squared. And then instead of our y, I can trade out that y for r sine theta. Now for the test, x's are gone, y's are gone, only r and theta, done. That's a polar form. You don't have to do more work. For WebWork, we're going to do one more step. Now, this step is going to look really weird because in all the rest of math, never, ever, ever divide by a variable. But in polar, you can divide by r. Both sides have an r. So we're going to divide both sides of the equation by r. So that leaves me with r equals, and then on the right, the r's cancel out. So I have negative 4 sine theta. So this is our WebWork answer. But this would be one of the ways to write the test answer. And that's the second half of the polar question on the back of the test, on the last question. So that's 10 points. In fact, one of the things I recommend on tests is don't do the questions in the order they're given to you. Do the questions you feel very confident in first. Get them out of the way so you know they're done. Then start working through the rest of the test. All right, let me find, I want to say it's problem 13. Now, I did record, yeah. I recorded my 10 o'clock class and I recorded my class yesterday going through all the questions. So I actually got the chance to like fully go through all the examples I wanted to on my video yesterday. So I'd highly recommend watching that one because in these I'm running out of time just because I'm explaining more. Like even in my 10 a.m. class, I was running out of time. But I have more time in that Tuesday, Thursday class, so I can actually like fully explain and get through all the examples. Problem 13 is the 2 triangle setup. And it is actually 2 triangles, and this is the same buggy question from section 5.1 that we all hate. But this is the way the calculation will work on the test. On the test, though, it will not be a 2 triangle setup. It will just be one really wide triangle. So it's an angle side-side setup, but not two triangles. Now, I don't give you the triangle drawings. You are going to have to draw the triangle yourself. Make sure you get the information in the right spots. So we're just going to work on like the setup here and what the first calculation would look like. So I draw my big horizontal, a long diagonal side, and then a short diagonal side. They gave me angle beta as 37 degrees. And then that short diagonal is the side opposite that. So that has to be side B, 6.36492. And then the other side they told me was side C. So that's my long diagonal side. So the angle opposite that is angle gamma. So I've got three things I know, one thing I don't know. So law of sines, I'm going to solve for gamma by using sine of gamma over C equals sine of beta over B. And now we're going to fill in the numbers we know. Then we're going to multiply by the 10. So now I have sine of gamma equals, leave some space, 10 sine 37 over 6.36492. And then we use the inverse sine function to get gamma by itself. Now I'm going to put a warning note on the side here. We need our calculator back in degrees because 37 is degrees. So if we run this in radians mode, it's going to produce the wrong number. The number might look reasonable, but it will be the wrong number. So inverse sine of 10 sine 37 divided by 6.36492. And we get 71.5 zeros and then numbers. So that means, because of the way this buggy problem works, we want 71 degrees for gamma. Now, alpha is the third angle. We've got two of them, so 180 minus beta minus gamma. And this gives us an alpha angle of 72 degrees. Then we just need to finish the calculation to solve for side A. So we'll have A over the sine of alpha equals, and then I go back to my B's, B over the sine of beta. So A over sine 72 equals annoying number over sine of 37. Multiply both sides by sine 72. And there is what we have to calculate for side A, which I think it came out to like 10.05 and some change. So on the test, that is all you will have to do. You don't have to do the second triangle. Now, on WebWork though, if you're going to finish the calculation for the second triangle, gamma prime is always 180 minus gamma. So whatever angle you solve for first, that's the first prime angle you solve for. And that angle is always 180 minus the original. So gamma prime ends up being 109. And then you can find alpha prime, and then you can find A prime. So again, I highly recommend that video from Tuesday, Thursday, but I'm also gonna pop this recording up on YouTube as well.